Okay. Chain rule for question number 10. The function y, as you see, sine squared, this is really thinking of sine as the base for the second power. So this is what this notation means for us. Now, for chain rule, what we've been studying is we have a function, u to the n, power rule with chain rule. And we have the chain here, where u is what you see here. This is the u. So when we differentiate this, this will become 2 sine pi over 2x. Now, really, if we had to go through every detail, that's 2 minus 1. And then we have to differentiate now sine of, let's move this over. Pi over 2x. Okay. Now, we're going to focus on this portion here. This again, this will be chain rule. But the chain rule we use here is when we have sine of u, the derivative of sine will be cosine of u, and then the chain portion here. So this becomes cosine pi over 2x times the derivative of pi over 2x. And that derivative is pi over 2. So we're going to have to really take a step back and see what's here. We get 2 sine pi over 2x. This is to the first power. This is what we see here. And then, don't forget we have this cosine pi over 2x times pi over 2. So cosine pi over 2x times pi over 2. Now, don't forget that we typically like to write or put that constant in front. So pi over 2 times 2 will just be pi. Okay, so we have pi sine pi over 2x cosine pi over 2x. Okay. All right, looks like it's okay. Number 10. Number 11, very similar. In that now you have secant of 2x as a base. And the power is 4 now, because this is the meaning of what you guys see here. That's really to the 4th power. And so what comes to mind is the power rule version of chain rule. And again, we have the chain over here. Don't forget that. So y prime will be 4 secant 2x. 4 minus 1 will be 3. And then we have to differentiate secant of 2x, because again, right in here is your u. This is the u part. So the next derivative is secant of 2x. So again, we have chain rule. secant u. Derivative of secant is secant tangent. And then don't forget the chain in chain rule. Okay. So this is secant 2x tangent 2x times the chain, which is the derivative of 2x. This is 2. So keep in mind everything that we have again. We're going to have to simplify this part first. We're going to write it all down together, which means I really have a derivative where it's 4 secant. That's going to be the third power because this is 4 minus 1. 4 minus 1 gives you that 3. Now, everything else that's left, again, is right here. So I'm going to move this a little bit over just in case I need the space. And we're going to write down secant 2x tangent 2x times 2. We're going to simplify a bit. Yes, we're going to multiply this constant 2 and 4 together, and then we're going to use properties of exponents down here. So remember, a to the n times a to the m is a to the n plus m. So this is what's going on now. But 4 times 2 is 8. We get secant to the fourth power of 2x tangent of 2x. There we go. All right. Number 12. Writing square root with a rational exponent, we can see that this is chain rule here with power rule. Okay. Now, u is right here. So y prime becomes 1/2 1 plus cotangent 2 pi x cubed to the 1/2 minus 1. So I'm going to put this down here because we won't have enough space, times the derivative of 1 plus cotangent 2 pi x cubed. So don't forget, this is actually the chain part here. So, all right. So I want to note this. I'm going to go over some details here. So just kind of note that you have the derivative of a sum which will be sum of derivatives. The derivative of your constant is 0. And then this is where chain rule is going to come into play again, because you got cotangent of u. And the derivative of cotangent is minus cosecant squared u, then times your chain for chain rule u prime. And that's going to be what we ultimately use here. So this would be minus cosecant squared 2 pi x cubed times the derivative of 2 pi x cubed. So this derivative now is 3 times that 2 pi x to the second power, which is going to be 6 pi x squared. And maybe you have to see the details with this one. As a note, again, what does it mean to differentiate 2 pi x cubed? Pull out your constant 2 pi. This is what I really did. And then use your power rule. 3x squared, which gave you that 6 pi x squared here. So if you can't see this power, it's really 3. So all we did was pull out that constant. So this is going to be what we have left. Now, we got to go back over here and somehow let's kind of put it all together here. It looks like we have that minus cosecant squared 2 pi x cubed times 6 pi x squared there. So that derivative, which is what we're talking about going right in here, is in purple. Now we have to use power rule here. It's 2 over 2. So let's start to put this together. Let's not forget that this is the first part of our work. And so y prime will be 1/2. That's going to be a minus 1/2, by the way. So y prime is going to be 1/2 times 1 plus cotangent 2 pi x cubed to the minus 1/2. That was the first part. Now I'm going to multiply the chain part, I guess. And I'll keep it in that purple color. Right? Looks good. But it'll be really minus 6 pi x squared cosecant squared. So it's minus 6 pi x squared. I'll put cosecant squared 2 pi x cubed here, 2 parentheses. Let's double check. Yeah. 6 pi x squared times a negative cosecant squared 2 pi x cubed. All right, let's see if we can do some simplification now. Y prime will be 1 over 2. 1 plus cotangent 2 pi x cubed to the 1/2. And in purple, I'll keep it that way. Negative 6 pi x squared times cosecant squared 2 pi x cubed here. So we'll put that parentheses. Now, that's just going to go on top. So I'm going to say we get negative 6 pi x squared cosecant squared 2 pi x cubed, everything over 2 square root 1 plus cotangent 2 pi x cubed. And wow, what a derivative. Anyway, that one was definitely a wow kind of question. Double check, see if I made a mistake. Sometimes, we take that negative sign and we put it at the same level. And that's fine, because just to kind of express this to you guys, you have negative a over b. That's the same as a over negative b, which is negative a over b. These small details, with these fractions that are negative, you have a negative numerator or a negative denominator, you put that negative sign at the same location here. So anyway. All right, I'll send this to you guys. I hope you guys enjoyed this. Have a good evening.